Before we get started on the next lesson, I want to first just review what we looked at last week in the previous lessons. And also to remind you, there is a quiz you need to take before you move forward. So once you're ready with what we've previously done, you're ready to take a quiz. Once you've taken that quiz, then you can move on to these. So when we have log base 2 of 16, remember the 2 is a small subscript, 16 is on the same line, so to speak, as the log. This means 2 to what power, we think of the log as meaning to what power, is 16. 2 what power, 2 to what power is 16, and the answer is 4. If we have log base 3 of the square root of 9, now we could think of this, we could evaluate this and say this is log base 3, the square root of 9 is 3. So what is log base 3 of 3? 3 raised to what power is 3? Our answer would be 1. And finally, we have the natural log. We looked at 2 logs that are on our calculator. They are the natural log and the common log. Common log is base 10. The natural log here is base e. We don't write the e, but we know the e is there. So e to what power is e? And that's also 1. So that's kind of what we looked at last week, just with how we use logarithms. Now, what we're going to look at today is the properties of logarithms, and then we want to use these properties to kind of solve some equations. So first, let's look at some properties of logarithms. We have log base b of m times n. If we have this multiplication inside of a logarithm, we can actually split this up as 2 logarithms with a plus sign. Now remember, we said that logarithms and exponentials are inverses. They're very closely related. So these properties are kind of similar. When you multiply, you add exponents. When you multiply what's inside of a logarithm, you add. For example, if I have log base 2 of 2 plus log base 2 of 4, this 2 and the 4, I can combine those and get log base 2 of 2 times 4, which is 8. And notice, this works. Log base 2 of 2 is 1. Log base 2 of 4 is 2. And log base 2 of 8 is 3. 2 plus 1 is 3. It works. The second property says if we divide inside a logarithm, m divided by n, we can subtract the 2. So if I have log base 3 of 12 minus log base 3 of 4, I can rewrite that as log base 3 of 12 divided by 4. Now, why would I want to do that? Well, if I have 12 divided by 4, that's 3. So this just gives me log base 3 of 3, which, once again, log base 3 of 3 is 1. And the final property, this is a big one we use a lot, is if we're trying to solve or have this k as an exponent here, we can move this k out in front. So for example here, I have log base 2 of 4 squared, which is the same as log base 2 of 16, which we said earlier is 4. Now, by this property, this third property, I could take this 2 and I could move it in front and get 2 times log base 2 of 4. Now, this is just going to be 2 times 2 to what power is 4? That's 2. So 2 times 2 is 4. Now you look at these properties and think, well, why would I do it both ways? Well, you wouldn't do it both ways. You know, if you had this problem here, log base 2 of 4 squared, you could either do it this way and get 4, or you could do it this way and get 4. You'd pick one or the other. So many times one will be easier. Sometimes you'll have to kind of use, but the big part here is taking this exponent and bringing it down in front. That is something we will use a lot. So those are our properties. So let's look at how we can use them and kind of solve some problems, kind of do some things to get us familiar with them. So let's say you're given two logarithms. Log base 4 of 5 is m. We have no idea what m is. And log base 4 of 3 is n. Just two logarithms we're given. And we want to find log base 4 of 15. So what I want to do is think, is there a way to use these top two logarithms to find log base 15? And when you do all these problems, you want to think, how can I use 5 and 3? How can I use 5 and 3 to get 15? Well, then we realize, well, isn't 15 5 times 3? And now going back and using my properties of logs, I could say this is log base 4 of 5 plus log base 4 of 3. And now I've gotten into the two top ones, and log base 4 of 5 is m, and log base 4 of 3 is n. So what we're trying to do is write these numbers based on 5 and 3. So log base 4, 25. In terms of 5 and 3, how do I get 25? Well, that is 5 squared. Now, this 2 we can bring down in front, and this becomes 2 times log base 4 of 5. And log base 4 of 5 is m, so this just becomes 2 times n. So how can I use 3 and 5 to get 15, to get 25, to get 45? So how can 5 and 3 equal 45? Well, 45 is 5 times 9. Let's start. And 9 is 3 squared. They're multiplied, so now I can split them up into log base 4 of 5, log base 4 of 3 squared. The exponent can go out in front, so log base 4 of 5 is m, and then log base 4 of 3 is n. That 2 in front gives me 2n. So when you do these, you're trying to get these numbers inside the logarithm in terms of these numbers here. Now I should mention here, and I don't think I've mentioned it yet, in all of these properties, our bases always have to be the same. If we go back to the base, the properties of logarithms here, you'll notice all the bases are the same. If you have two logs of different bases, these properties don't necessarily hold up. Another way we're going to use these. Write an expression as a rational number or as a single logarithm. So I want to combine these. So I use my properties. First, since I have a plus, this can be log base 3 times 6. So this is log of 18 minus log of 2. And finally, when I subtract, that's 18 divided by 2, which gives me the log of 9. And that's just a single logarithm. That's a common log, base 10. I can't simplify that any further. Try another one. Log base 2 of 48 and 1/3 log base 2 of 27. But before I can deal with this subtraction, I have to remove this 1/3 and move it up there. So log base 2 of 48 minus log base 2 of 27 to the 1/3. How well do we know our cube roots? 27 to the 1/3 power is the same as the cube root of 27, which is 3. So this is log base 2 of 3. Now since I have my subtraction, I can divide. which is log base 2 of 48 divided by 3 is 16, and then log base 2 of 16 is 4. So in these kind of problems, sometimes they'll simplify down, and you'll just have a logarithm that you're left with, a single logarithm. Sometimes you can simplify them all the way down to a number. You just keep going until you can't go any farther. You may get a number, or you may get a logarithm that you can't simplify. The next thing here, express y as a function of x. So from previous chapters, we remember y is a function of x. We should end up down here with y equals something. We shouldn't have any logarithms left. Necessarily, we may have a logarithm left, but it should just be y. Now, there's two kind of problems we're going to see here. The one on the left here, we have logarithms on both sides. It's going to be one type of problem, one type of equation that's going to require a certain way to solve it. And then over here, we have a logarithm on one side and no logarithm on the other. That's going to require a little different method of solving. First, let's look where we have two logarithms, one on each side. What we want to do when there's a logarithm on each side is we want to get both sides just to the log. This 2 in front I can bring up to get 2 squared. So I have log of y equals log of x squared. So now both sides are the common log. So all I have to do is set what's inside of them equal. So y equals x squared. So a logarithmic equation with logs on both sides, I just get the 2 logs and then set what's equal inside. If I only have log on one side, now I'm going to do exponential form. If you have one logarithm, you do exponential form. 2 logarithms, one on each side, you got to get them equal and then just take what's inside equal. So if I do this in exponential form, it's going to be 4 to the 2x minus 1 equals y. 4 to the 2x minus 1 equals y. Now let's look at where that came from. 4 to what power is y? 2x minus 1. So 4 to this power is y. And we're trying to express y as a function of x. We're already done. I already got y. I solved for y. So in these equations, what we're doing is we're solving for y. 2 more, just to kind of simplify. E to the 2 times natural log of x. Well, what can we do? We can take this 2 and move it up. So we have e to the natural log of x squared. Over here, I can do the same thing. 10 common log of 6 squared. Now, if you remember in the homework last week, we did a problem like this a number of times, where we said if the one I think was 4 to log base 4 of like 3. And we said the answer is just 3. Because the 4 raised to the log base 4 basically are inverses. They cancel each other out. So here we have e to the natural log of x squared. E to the natural log. E to log base e. Those two are inverses. They kind of cancel and we just get x squared. 10 to the common log. 10 in the common log. Log base 10 kind of cancel and we just get 6 squared or 36. So if you have the same base for the exponent of the log, they just kind of cancel. That's similar if I have log base 5 to the 5 cubed. That's also just 3. The bases kind of cancel. Now, here's a problem where I said can't do it, different bases. We did a problem similar to this on the homework last week. We've expanded this a little bit. So the key is, let's write this in exponential form. 5 to the 0 is log base 2 of the log is 4x. But 5 to the 0 is just 1. Right, exponential form again. 2 to the first is log base 4 of x. Let's do it again. 4 squared equals x. And now we've gotten rid of all the logarithms by writing it in exponential form over and over and over again. And x squared, or excuse me, 4 squared is 16. All right, we are ready for the first homework, which is the properties of logarithms.